Welcome back. This is section 5.1.1, which is basics of continuous density function. So far, we have seen discrete probability density function. Now we're going to talk about continuous density probability density function. Now, continuous, let's go ahead and take a look at what it means by continuous random variable. Continuous random variable. A random variable whose outcomes are measured, they are not counted. Now you might say, Miss, what exactly do you mean by that? Look at this picture here. If I ask you, how many balls did he hit? So you might say 2, 3, 4. But if I ask you the speed of the balls, then it is continuous. You will give me in probably 36.2 miles per hour or 47.2 miles per hour, right? So you can see the difference between discrete and continuous. Now let me go ahead and ask you, how many vacations did you take this year? Let's just say you give me 0, 2, 1, or maybe 4. But if I ask you, how long was your vacation? Then you might say 72.2 hours or 12.3 hours or 1.2 days or 1.6 days or 7.8 days. You see the difference? Now let me go ahead and give you another example. If I ask you, how many times do you go to work per week? You might say 5, 4, 3. But how long is your distance? Then you'll say 12.1, 36.2. See the difference? So when the answer is in decimals, that is it's continuous. When it's a whole number, that is it's discrete. How many houses do you have? 1, 2, 3. What's the mortgage? Then it's going to be probably 1200.63 cents or 3000.72 cents. Do you see the difference? So that's the difference between discrete and continuous. Now, a general note. Sometimes your discrete and continuous random variables could be slightly ambiguous, but we will take a close look. Let's take a look at the example. Here, if you say you have the number of books in your backpack, 2, 3, 4, 5, but the weight of the books 1.2 pounds, 2.3 pounds. You see, the number of books is discrete and the weight is continuous. If I ask you the number of miles to the nearest mile, you will say 12, 13, right? But if I ask you the distance you drive, and I'm not asking you to round off, then it's going to be 12.3 or 13.4. See the difference? All right, now let's take a look at the important part. Properties of continuous probability distributions. A graph of a continuous probability distribution is a curve. So keep in mind, it always looks something like this. Oops, I think I don't have that. Yeah, it looks something like this. Probability is represented by area under the curve. Very, very, very important. So when I ask you for probability, I am asking you for nothing else but the area under the curve. Okay, very important. The curve is called the probability density function, abbreviated as PDF. Not the PDF file, but it's abbreviated as PDF. All right. We use the symbol f of x to represent the curve because it's a function of x and where x corresponds to your variable. Now we define the function f of x so that it's the area between the x-axis, right? Between it and the x-axis equal to the probability. Now we'll take a look at the examples. I'll have to make sure I read these first so you know these are the important notes. In the study of probability, we know that the maximum probability is 1 and the maximum area is also 1. So if I ask you for area, that is nothing but I'm asking you for the probability. So if I'm asking you for probability, it's the same as asking you for area under the curve. So probability is nothing but simply your area under your curve. All right, so now let's go ahead and take a look at different types of distributions. So you will have a uniform distribution. Everything is uniform. So there is no curve. When I say uniform, your graph is going to look something like a box. Very, very uniform. Everything is same. Exponential. So it's either going to go way too high or it's going to go way too low. Exponential functions. Normal distribution, 90% of the data follows normal distribution, which is called the Gaussian distribution, or it's also a bell-shaped curve. That's not a proper bell, but you get the idea. It's a bell-shaped curve. All right, let me try one more time. It's a bell-shaped curve. All right, help me out here. There you go. That's the best I could do. Okay, now let's take a look at our probability density functions here. This is a uniform distribution. As you can see, it's perfectly straight. Exponential, boom, going down. It could be skewed left or it could be skewed right sometimes, something to the left or to the right. This is a bell-shaped curve. Okay, so you have three types: uniform, exponential, and normal. Majority of our data is a normal distribution. So this is a very important distribution. So your normal distribution is a very important distribution. All right, now let's go ahead and take a look at the example problems. So I had to log in as a student here, and this is the first question I have. Given the graph below, it's the PDF, probability density function. And they're asking me, remember it's represented as f of x. What is the probability of x, which is less than 7 and greater than 5? That means x is in between 7 and 5. Remember, probability is nothing but area under the curve. So if I ask you, what kind of distribution is this? Do you see a curve or do you see something constant? I see something constant, so this is a uniform distribution. And what are they asking me? They're asking me, let's say, okay, from 5, oops, not a perfect line, still not a perfect line. How do I draw straight lines? Yeah, from 5 to 7. There you go, 5 to 7. And I'm looking for area under the curve, 5 to 7. So this is my, so when I look at it, you see a rectangle, don't you? So this length is 1/8, and this is 1, 2. This is 2. So remember, probability is nothing but your area under your curve. In this case, I have a rectangle. So probability is area of the rectangle, which is 1/8 times 2, which is 2/8, which is 1/4. Let's see if I got this right. Okay, I have to click escape. 1/4, and let me submit it. Yep, keep it up. Very good. As you can see, this is a uniform distribution, base times height, and that's what I have. Now let's click continue, and let's look at the next problem. All right, so the next problem here is they're still asking me for the probability between 1 and 4. So if I graph it, this is probability between 1 and 4 is right here. So this is a triangle. As you can see, this is a triangle. And oops, that was a bad triangle. And area of a triangle is half times base times height. So I have the half here. My base is 1, 2, 3, 3 units. Times my height is 3/8. That's what they have here. Right? So if I go ahead and multiply 1 times 3 is 9, 9 times 9/16. 8 times 2 is 16. Now let's look for the answer, 9/16. Do I have it? Yep, all the way here. So let me go ahead and check that. I'll have to click escape so everything is gonna get erased. Escape, 9/6. And let me click submit. Very good. And there you go. That's the explanation. All right, let's go ahead and tackle this question here. The weight of a single sheet of paper is 4.5 grams, but can vary. Let W be, let W be a random variable. Remember how I represent a random variable with capital letter? And weight of a single paper. The probability density function W is given below. So W is a random variable that represents the weight. The weight can be So this lowercase w could be the weight that represents the value, which is 4.5 grams, or it could be anything. But the capital letter represents the random variable. That means it keeps changing. Now the probability density function is given below. So what they're asking us to do is move left and right siders so that the area of the blue shaded region represents the probability that the weight of a single sheet paper is between 1 and 12 grams. So let me click escape here. They're asking me move the left one between 1. So I'm moving the left one to 1 and the right one to 12, between 1 and 12. Is that what they said? Yeah, 1 and 12. And then I click submit. Great work. Now what they're asking me for is the area. So here is my area under the curve. The area under the curve is 0.877, no, 15847. Okay, let's see what they want us to do. All right, continue. And they're saying, give me the answer in percentage, round to the nearest tenth of percentage. So when I go back here, my area in percentage is I move the decimal 2 units to the right. So I have 87.71, rounding off to tenth. Tenth is 1 decimal place, 87.7%. Let me try that. So I'm going to click escape, go all the way down and type 87 point, what was that? 87.7? 87.7, yes. And I click submit. There you go. It did not let me move forward with the homework. It just said you did it. But if you have any questions, please make sure you take a screenshot and email it to me. And don't hesitate to contact me through email or through Teams.